Hi, hello everyone. My name is Abraham. Um, I found this paper interesting, and that's why I picked this paper. It's talking about capability maturity model integration for optimizing object-oriented analysis and design. So this is information about the paper, and here's the website, sciencedirect.com. Uh, is recent is It was published in 2015. Um, these are the authors of the paper. And about this paper, the authors of the paper proposed capability maturity uh, model integration for object oriented analysis and design. We know that the popular method used in analysis and design is object oriented analysis and design. We measure the results of object-oriented analysis and design using a validation and verification technique. But we still need to improve software development. And this call for the paper by proposing CMMI, Capability Maturity Model Integration, to improve process in creating products and services within an organization. Optimization actually takes place by improving software development process. So using CMMI, this is a quick introduction about the paper. The quality of software is actually determined by its development process. The result of each step in software development life cycle must be assured to have good quality to contribute in software product quality. As initial steps in software development lifecycle, analysis and design phase plays vital role in defining software scope from the perspective of stakeholders and translating them to engineers using visual artifacts. UML verification techniques. Object-oriented analysis and design is commonly used in analysis and design phase of software development and is a powerful method for analyzing and capturing user requirements as well as designing applications by performing visual artifacts to obtain better software quality throughout software development lifecycle. There are several techniques in the UML diagram of object-oriented analysis and design. So these are validation and verification techniques. We have object-oriented reading techniques inspection, and which is a technique for early defect detection in software artifacts. That's when you want to really uh, quickly detect any kind of defect in software artifacts. Uh, Guided inspection that uses test cases to determine if the model is complete, correct, and consistent. The most popular technique is the use of checklist that represents some list of verification derived from software quality standard. So these are the standards for software development. We know the high standard 830 is part of the standard, for software requirements specification. There are a lot of standards available during software development process, which focus in every phase of software development cycle, and and sometimes uh, this creates difficulty to compile all of those standards for creating checklists in verification and validation of UML diagrams. These are the standards for software development, and this is IE software lifecycle, software quality assurance, configuration management, test documents, requirements, specification, verification and validation, design, description, project management, and user documentation. Capability maturity, model integration. So to address IE standard issue, the authors of this paper proposed the use of CMMI as reference model in developing the checklist. So to improve performance in terms of software development process, CMMI is a best practice, and the research aimed to optimize object-oriented analysis and design results by creating a checklist which derive from CMMI. So the two issues are we have okay, can CMMI uh, be used to optimize object-oriented analysis and design, particularly UML diagrams? Or can CMMI how CMMI is used to optimize object-oriented analysis and design? So this takes us to CMMI for optimizing object-oriented analysis and design. There are currently three sort of CMMI, which are CMMI for development, CMMI for acquisition, and CMMI for services. So I'm gonna talk more about CMMI for development because it's a directive model that involves activities for developing both products and services. Is arranged based on three concepts, which are process area, specific goals, and specific practices. There are 16 process areas contained in CMMI. Process area definition is a series of related practices in an area that, when implemented simultaneously, fulfill a set of goals considered important for making improvement in that area. Moreover, maturity level apply to an organizational process improvement achievement across multiple process areas. So these levels are means of improving the processes corresponding to a given set of process areas. So we talk more about process area. So process area, the process area used in engineering process of product or services in the CMMI development is a requirements development process. That's RD. This process area is meant to be used in engineering process area at maturity level 3. We actually have levels from 1 to 5, but the purpose of requirement development is to elicit analyze and establish customer product and product component requirements. So process area consists of three specific goals, SG, that is analyzed into several specific practices, and five generic goals, which are explained uh, into uh, some generic practices. This takes us to CMMI checklist criteria for UML diagrams. So the specific goals and practices summary is in table 1. So this uh, for we have specific goal 1, 2, 3. Under specific goal 1 we have uh, specific uh, practices. 1.1 as elicit needs, uh, trans, 1.2 transform stakeholder needs into customer requirement. These two are under specific goal 1, that is develop customer requirements. So under specific goal 2 we have develop product requirements. Under that, we have established product and product components, allocate products, component requirements, identify interface requirements. But these are under specific practices. 2.1 corresponds to established product and product component requirement. So these actually they they follow the same specific goal, like we have in specific goal 2, and the same thing with specific goal 3, and this has specific goal, and these are specific practices. So I'm gonna this is table 1 and this is table 1, this table 2. Before I talk about table 2, I'm gonna go to table 3, because here in table 3 we have CMMI checklist criteria. These are the criteria for UML diagrams. Any UML diagrams, these are the criteria that will these are the checklists for CMMI. Number 1, under the general we have unique name, reflects the functional role and purpose of the use case, includes all relevant actors, avoid ambiguities, omissions, and impreciseness in the UML diagrams. So under each UML process area we have these, like specific goals, specific practices, specific goal 2, that's specific goal 2.1, specific practice 2.1. So we use this CMMI process area as checklist criteria for UML diagrams. So if we follow these criteria we can compute these, and actually the outcome of these we see in this table 3, that is CMM high implementation level category. So if we want to know whether in our UML, maybe if the checklist in the checklist, if UML is being fully implemented, That is, we accurately identify all the criteria in the checklist. Then we can say it's fully implemented, and the score range from 76 to 100. If it's largely implemented, then the score is between 51 to 75. If it's partially implemented, then the score is between 26 to 50, and so on. So we go to optimizers, and then we will see the results that the authors they put in the paper. So the maximum uh, compliance for the CMMI criteria is actually 240, and the paper they got something around 180. So the idea of optimizing the object-oriented analysis and design during software development lifecycle using requirement development process area is derived from the basic concept of the CMMI to improve process in an organization, particularly in improving software development process. So the summary of the score criteria is compared to maximum score. The maximum score of the checklist is 240. So the percentage of the score is then classified into four categories of implementation, as I've shown here in the table 2. So evaluation and results. Object-oriented analysis and design results using the CMMI checklist. So the score for the entire UML diagram in every functional of the system is quantified based on the CMMI checklist. If you go through the paper, you're gonna see you use case diagram, class diagram, and activity diagram. So based on the entire UML diagrams, uh, uh, the functionality of the system is quantified based on the CMMI checklist. So that's how you know the functionality of the system. So from the scoring perspective, then it can be obtained whether the UML diagram comply with CMMI model or not. So the scoring was done by an analyst, and for this is the result they got in the paper. They got around 185. So based on this criteria, so the fulfillment of UML diagram towards CMMI model reference, which quantify using CMMI checklist, obtained total score of 185, and it actually fulfilled CMMI checklist, which is if it's 77%, then this is fully implemented. This might be a mistake. So then this means that most of the entire UML diagram phase comply with the criteria in CMMI in requirements development process area. So conclusion is that object-oriented analysis and design method is a critical source in determining the quality of software development process. CMMI can improve accuracy for object-oriented analysis and design results, and that's where optimization come into place. And applying the CMMI checklist to quantify whether the object-oriented analysis and design results are quite good, then this can reduce organizational cost or failure in the next stages of software development process. So here is the conclusion, and if there is any questions, I'll be happy to answer the questions. Thank you for your time. It's the end of the presentation. I'm gonna stop my video. Thank you.